graph enthusiast to graphstuff.fm, a podcast all about graphs and graph related technologies. I'm your host, Jennifer Reif, and I am joined today by Andreas Kollegger.
Hey.
And we have a great guest today. Joining us is Lance Martin. Lance is a software engineer at Langchain, working on the open source library. He's done a lot of work on RAG and open source LLMs. Before Langchain, he spent several years working on computer vision for self driving cars and got a PhD from Stanford. So, welcome, Lance.
Great to be here. Thank you so much.
Yeah, thrilled to have you on today. Could you just maybe kind of just to get us rolling, I guess, tell us a bit about your backstory, maybe how you ended up at Langchain?
Yeah, absolutely. Yeah, so kind of like you'd mentioned, I spent quite a few years working on self-driving cars. Like a lot of folks who are kind of doing machine learning, kind of in the late 2010s, early 2020s. Computer vision and self-driving was a really interesting place to be. I think with like the advent of kind of ChatGPT and the fall of 2022, it kind of changed a lot of people's views of LLMs and what they can do. And it certainly got me excited, got many people excited. And in early 2023, I started just hacking on the side. And I encountered a really cool app called Paper QA, which is a RAG app for scientific literature. And I said, "Oh, this is pretty neat." Allowed you to do question answering over your papers. And I've been, I read a lot of papers, so I thought it was pretty cool. And it was written with LangChain. So I said, "Oh, what's this LangChain thing?" So I kind of picked it up through that and started playing with LangChain and ended up building a few apps myself, which I just put out there and hadn't been on Twitter in many years and kind of spun my old Twitter account back up and put out this thing called Lex GPT, which is like a RAG app over all Lex Friedman's podcasts. So I used
Oh, cool.
Whisper to transcribe them to text, and then I embedded them, and it was a lot of fun, and like that got some like fun attention. And I basically built a number of these kind of RAG apps. I did like Lex GPT, and then I did the Tim Ferriss podcast, and then I got to know Harrison through the course of kind of building these apps just via Twitter. And we kind of had some nice conversations. I met him at a few hackathons, and then he finally said, "Would you like to join Langchain?" So I joined kind of in last spring as one of the earlier folks. At the time, we were still in a venture capitalist office. Then we moved to our space. We hired up. We now have about 20 people, but I was kind of there from those very early days, and it's been a lot of fun. And I still work on RAG, so RAG kind of hasn't gone away, but it has evolved. But it's been a fun ride for sure.
That sounds amazing. Like, and the journey you described there, I feel like it's kind of similar to like maybe everybody's exposure to RAG. Like you kind of start with like, okay, you discover something that somebody's done that's interesting, and like, okay, how do they do that? And like it's the classic curious engineer mindset, like, okay, let me dig into the details and kind of unpack this a little bit.
Yeah, that's right. Yeah, that's right. And I think one of the reasons why RAG kind of hasn't quite gone away is I think Andre Karpathy, he had a really nice Twitter post talking about LLMs are kind of like the kernel of a new kind of operating system, as opposed to just thinking about them as like, a thing you pass text into and you get text out. It's more like it's kind of like a kernel or a general compute engine that can be connected to lots of external resources
Yeah.
like tools, like sensors. And one of the big ones, of course, is like databases. And so just in the same way we have like a kernel, we have disk, we have LLMs and data sources, graph
Hmm.
dbs being one big one. And so like RAG is it's kind of like a very central component. If you think about these things as like kernels, a new kind of operating system, you're always going to want to connect that kernel to external data sources. And like that's what RAG is. So it's like a
Yeah.
very central idea. And so I think that's why it was never quite, it wasn't like just like a flash in the pan to go RAG. It's like a very central component of these systems that, of course, will do many things beyond RAG,
Hmm.
but it's kind of like a centerpiece in the same way, like, every operating system has the kernel connected to disk,
Right.
like every LLM app is very likely going to connect to some external data sources to get information that's current or otherwise not present in the pre-trained weights. So that's kind of it. And so it's become like a very powerful general idea.
I love that framing that you're describing there, and it's a great way to think about it. That it's because sometimes like in a sort of fear of extinction kind of perspective, people think, oh my gosh, AGI is coming, it's going to do everything, and we'll just be sitting there, asking it to do things or something. But the practical reality is like there's still going to be a bunch of systems that exist, and this thing has got to be integrated with those systems. You still have to build the systems. So all the patterns you're describing like are a great way of thinking about it. It's not like you're not going to build a UI and ask the LLM, hey, what's the state of this toggle switch?
Right.
Right? Like you're still going to have memory, you're still going to have disk, you're still going to have databases, and you've got to make all these things fit together, right?
Yeah.
Right. Exactly. And that's kind of why I think, it's also the case that LLMs are going to get, increasingly more powerful without question. But it's also true that it'll never, the pre-trained models will never encompass all the data that you want them to encompass, of course. They won't have your private data. They won't have recent data. And so this is also essentially why kind of RAG and the ability to connect it to external data sources is always going to be of high interest and importance, I think.
Right.
Yeah. For some users who maybe aren't super familiar, could you maybe just step
Yeah.
back a second and explain
Mm,
kind of what Langchain is and
yeah.
why it's there?
Yeah, absolutely. Yeah, I think the way I think about LangChain in simple terms, it's basically an application development framework for LLMs. So for example, right now there's hundreds of different LLMs. There's dozens of different, maybe even hundreds at this point of different types of databases and vector stores. Uh, Dozens of maybe hundreds of different embedding models. And LangChain's a kind of a very general application development framework that lets you kind of compose these things very easily into chains. So the most simple kind of abstraction or idea in LangChain is that you have a chain. So like a RAG app is just a chain that's composed of like a prompt, a retriever, like a vector store, or a graph, and an LLM. So that's like the core of the app, right? So you basically have this retriever, and again, that can be numerous different types of databases. But say it's a retriever that retrieves documents. You have a prompt that you push those documents into. You have an LLM that those documents then, or that prompt is then fed to. You also have embedding models that are used to index the documents as well. But LangChain makes it very easy to compose these things. And I think one of the reasons why LangChain got really popular is there is kind of this like paradox of choice. There's
Hmm.
so many different LLMs, there's so many different vector stores. LangChain kind of created a common abstraction on top of all of them.
Mm.
So if you're building an application, and I do this a lot, right? So say I have a RAG app that's using like Pinecone for a vector store and OpenAI as my LLM. I want to switch that to use a GraphDB as my data store, and I want to use a different LLM. Like I want to use like a local LLM. Those are like very simple plug and play things you can just swap within LangChain.
Right.
And so I think
Right.
that composability and swappability are things that became really popular in terms of the open source library. I will mention LangChain's not just that because we kind of have this open source library, but we kind of get into like the nuts and bolts of our actual business is we sell observability. So we actually have this thing called Langsmith, which is an observability system that sits really on top of LangChain. Now, it doesn't need to be used with LangChain, but it's a very general system that has like prompt management. It has tracing and evaluation for chains. So it's more of an observability tool, and that lives on top of the open source library, but it's independent. And that's actually kind of our product out there
Hmm.
today. And we're building new things on top of them. Indeed, we have something called LangServe, which is basically a way to very easily deploy chains. So if you have a chain built in LangChain, Langsmith gives you observability, like monitoring evaluations over that chain.
Mm.
LangServe gives you the ability to deploy it as a web app very easily.
Mm.
So that same code you use for prototyping, you can basically, in very, very simple steps, turn that into an endpoint that's exposed to the web. And so then these chains become like microservices that can connect with other chains, and
Right.
and
Right.
that's kind of the idea. So those are the two big things that sit on top of our open source library.
Okay.
So then, as developers, you don't have to worry about thinking about, I need to build a whole application around this stuff. It's like, okay, just let me worry about the chain, and then
Right.
that gets deployed straight to the service.
That's the key point. That's exactly the point. And actually, I'll share in the show notes a video on this that I recently did. But the idea is very simple. We have this expression language called LangChain expression language, a very easy way to
Yeah.
compose these elements. So you can kind of compose a RAG chain using LCELs, what we kind of abbreviate it as. So you base it, it's kind of like bash and like basically defining a pipe, right? You have like, have your retriever, your prompt, your LLM, and then that's like a little pipe, right?
Mhm.
Mhm.
Now, every chain you define in Langchain in this way has a common set of invocation methods: stream, batch, invoke, right? And so what happens is if you've defined this chain, you can run it locally in a notebook, you can stream, you can batch, you can invoke, no problem. You can use LangServe with like very few steps to turn that into a web app such that those invocation methods, stream, batch, invoke, just become HTTP endpoints. So then you have an
Nice.
endpoint that is stream, an endpoint that is batch, an endpoint that is invoke, that then you can call. And we actually, with that, we ship a little playground that's just like a UI.
Mhm.
So it's like the endpoints of your chain the invocation methods of your chain just become endpoints in a web service, and that's it. Super simple. And then you can interact with
Nice.
that via many different ways. You can with a playground, you can curl it. So it's like the same code. Your chain then becomes like a service, and that's it. It's pretty simple.
That's really awesome. That's really cool. I mean, that's such a great thing. Like you can then just focus on like doing the actual chains themselves and not like all the I've got to build the app and then I've got to
Right.
put it into a container, figure out how do I deploy it to, Amazon, Google, whatever. Like it's going to be,
Right.
hosted by you guys. And I
That's
guess
right.
there's options then for scaling it up as you need to, and you got all those kinds of opportunities.
Yeah. There's actually two things to highlight on it that's kind of nice. So one is we have a whole bunch of pre-existing templates that
Mhm.
you can just use. So like, in fact, with Neo4j, we have a few of them. So you guys have actually done a lot of really nice ones. And actually, I did a video. I don't know if I didn't mention this, but I actually have a video highlighting one of your templates and how to turn it into a web app that
Oh,
just
cool.
works out of the box. And so what's pretty cool is we have this library of existing templates you can just use. So like basically chains for different functions that like just work out of the box. It has like GraphDB rag, it has regular rag, private rag, summarization, extraction, a bunch of templates. We have a template library. You can very easily just like take those, basically download them, have this template, modify it locally if you want, and then just turn it into a LangServe app
Mhm.
and run that. And like you were saying, so maybe point one is we have this template library of different templates, but point two, we also have what we call hosted LangServe. So basically, you can spin up this LangServe app that you can run locally. If you want to host it, we can just do that for you very simply. And actually, the video I have with Neo4j goes through exactly that process. It's like 2 clicks basically inside your kind of the Langsmith
That's so
basically
nice.
page. Yeah, you can just click deployments, pick the repo which has your LangServe app in it, and then it just is deployed and we host it for you.
So nice.
So actually, the Neo4j semantic template is a hosted LangServe app. I'll share it in the show notes.
Cool.
Jen,
Yeah,
I'm gonna expose our kind of Java background here a little bit. I mean,
yeah,
the tooling you're describing sounds so awesome, and it makes me think back to like things like Apache Camel, and kind of even like the Spring World a little bit, where like those are
Mhm.
frameworks that were built around doing data integrations. On the Spring side, it was very OGM-ish, kind of
Yeah.
based on that, and then it had things that came out around it, and it was a great step forward for Java land. But there was still so
mm,
much heavy lifting to be done, right? Like it was just a lot to kind of get through. And I love
mm,
how like all the things you guys have done, like it's been a year, right? And then you guys have
yeah.
covered so much ground. Like just kind of the developer experience out of the box is like you've been thinking about it, like you're already kind of ahead of like where people are going to need things,
Yeah.
which is fantastic.
Yeah, I mean, we've been working pretty hard, and I think there's still a lot of opportunities and like places we need to do better. Um, like I'll give one example and what we're trying to do to make it easier. Like I think that um, well, we saw one big pain point was this idea of how do I go to production, right? So like I'm in Langchain, I built my little prototype in a notebook. How do I productionize it? And that's kind of what motivated, okay, cool. Langchain expression language is like we kind of standardize the way of building chains. And then if you do it that way, you can turn it into production really easy with LangServe. So that whole arc of work was motivated by the need to like how do you use the same code for prototyping production. So that was like one big pain point. We saw that, we like tried to fix that. But I will say Langchain expression language is not the easiest to pick up for everyone. Like for simple stuff, it's like pretty easy, right? But then like if you get into weird, exotic chains, like it's non-obvious, and I get confused sometimes. And so actually one thing I've been working on is it's kind of like a code assistant for Langchain expression language. Basically text, like it's actually related to your world. We have like text to cipher, right? Because cipher can be confusing. Text to LCEL, basically. Like,
Oh, really?
right. So
Okay.
same idea. Yeah. I'm working on it. We hope to put it out next week, and of course we'll keep iterating up. But that's an example of like
Yeah.
you solve one problem, the problem of like build it like a kind of standard way of architecting these chains, which has a lot of advantages. Like then the invocation methods are common. You can easily support production, but it comes at a cost of, well, now people have to like ramp up on this like new way of building things. And we got rid of a lot of our old methods, which were kind of like these nasty abstract things like it'd be like, some class like vector DB QA chain, and we've moved all that to Langchain expression language, just laid out as this chain using LCEL. But people need to learn that, and so we're trying to solve that problem with like a LCEL kind of coding assistant. And
Okay.
it's similar to what you guys have had to deal with, maybe with like Cipher, and it can be hard to ramp up on Cipher. So what are ways to like
Totally.
onboard
Yeah.
people to Cipher? Like domain specific languages are tricky.
Yeah.
Right.
So
Totally.
right. I would say kind of like there's trade-offs, like you push to solve one problem, you do introduce new problems and you have to go fix those. So we still have a lot of work to do, I would say.
That's the reason why technology is never boring, right?
It's never boring. It's never boring.
The
Yeah, that's
goalposts
exactly
always
right.
move away. They always.
Yeah.
The goalposts always shift, exactly. So spend a lot of all this time. Okay, let's solve the production problem. Now we have the problem of like LCL is tricky, and so we need to solve that problem. And so it keeps it interesting for sure. And I actually really like working on code assistants. In fact, I don't know if you saw, there's a really interesting paper, Alpha Codium, that came out recently.
I haven't seen it.
It's like a really interesting idea for building a coding assistant that incorporates um, basically feedback in the loop, where you ask a coding question, it produces a few answers, it auto generates tests for itself, it evaluates those tests, and it feeds back on itself then in like maybe retries. And so
Huh.
this idea of building like assistants that are more than chains, that have some degree of feedback, that brings up like agentic workflows and agents. And we have kind of a new thing, LangGraph, that is meant to support like cyclic workflows with agents, where you can enumerate every step in very precise terms that you want your agent to take. And so that might be one big idea we explore with this coding assistant. Like, for example, not just like one shot, like generate one answer, but like look at the answer, evaluate it, go and try to generate a better answer. So kind of run the agent or the assistant in a loop rather than just like as a one-shot chain. So I think that's just another thread that I'll highlight that like we think is pretty interesting.
So I'd love your feedback about like a thought here that you're provoking a little bit. Like there's kind of an evolution of like the expressiveness that you're kind of trying to work through here, and it reminds me of, so like with Neo4j,
Right.
back in the dark ages, it was just a Java library, right? And so the only way you
Right.
could do stuff with the graph was literally writing Java code to do stuff. And
Right.
kind of the step past that was there was a more of a DSL approach, which was kind of done in a language called Groovy, which is still,
Okay.
fundamentally runs on the JVM. It's, kind of Java extended in some ways. And that was nicer than just straight to Java because it was more succinct. It had better composability for doing graph stuff because it was purpose built as an API. And that got us a little bit further. And then we realized, okay, actually, we really want a purpose-built language that will be either
Right.
interpreted or compiled, and like that got us all the way to Cipher, and bringing in
Cipher.
elements of SQL, bringing in elements of
Yep.
functional programming. How far along that continuum do you think sort of LCL, is there like an evolution there? You can imagine like actually at some point it's going to be a language itself that is not a Python-based language, it's a language.
Yeah, that's an interesting point. I'm actually not sure we want it to go that far, because I think that we really want it to be just a way to compose building blocks together in like a hopefully as simple as possible way. Um, and I think that with like template apps
Mhm.
and with like the LCell teacher or the coding assistant, I think we like don't we want to make the load on users very minimal. Like I
Yeah.
think we want to try to move away from having anyone need to learn a DSL for Langchain because like completely understand the need for a DSL for like a database, like a SQL database, of course, graph as well, because like there's many different ways you'd want to access data from such data sources, and like you need a very expressive language to capture all of that. Whereas with LangChain, we're just an app development framework. We basically want to give you easy ways to glue Lego pieces together. I don't think we want to
Right. Right.
build something that has a very very high degree of complexity. I think we want to manage that complexity both with like maybe tools to just kind of automate the process for you if you need to compose a really complex chain, or like templates that just have pre-baked chains you can just use out of the box.
Right.
So I think we want to move in the direction probably of making it easier. um
Yeah, so
would be
sort of the
my
out of the box
sense.
experience will be enough that's there. Like it's a bit of a Pareto principle. Like you'll end up with what you've got. It'll cover 80% of what people need,
I
and then
think
maybe
so.
there's some effort for customization in like some extreme cases. But kind
Sure.
of the out of the box experiences, everything's there for you. It's not that many variations, even across different data sources. You'll be able to identify the problem
Yeah,
space. So somebody new will be able to come in, kind of get up to speed pretty quickly by just focusing on like the tooling you've got and the LCL language, right?
I think so. Yeah, I should think about that more. I mean, my sense is the expressiveness you need in like a DSL for querying a database like SQL or Cipher is like very high. So that's like very
Totally.
high in the expressiveness spectrum. For something like what we're trying to establish, I don't have great comps. That'd be an interesting thing to think about. But like we want, it's really just it's like a means of composing chains. There's certainly there's a lot of creativity in the way people will lay out these chains, but there's probably like a pretty common set of design patterns that people will
Yeah,
like.
yeah,
I'll give an example, right? Like a lot of people want to build a RAG chain. And I think a lot of the diversity will come from like they want to connect with this database, they want to connect with this LLM or this embedding model. So you get a lot of diversity in terms of each component, but the
mhm.
layout of the chain is the same for everyone, if you see what I'm saying.
Yeah,
Like I think
yeah,
the diversity more comes from like the blocks rather than
mhm.
like the nodes are connected between them. Like we could get into kind of the different ways of laying out RAG. There is some variation there, but I
Mhm.
think a lot of it is just like swapping in different blocks rather than like different exotic connections between them. If you see what I'm saying.
Yeah, yeah. That does make sense, right?
Um,
And so, actually, if
yeah,
you could thinking back to like Jennifer's earlier prompting on this, because I keep forgetting as well. Like, so like within the if somebody's new to this stuff and is just getting started, okay, what is
mm,
RAG? Kind of understand the general flow of that. The first step is always a little QA chain, right? Like that's the kind of first step for people. Do you think there's a natural progression like from there? What do you recommend is like, okay, you've done that. If you want to get a little more sophisticated, what's a good next step for people and like where do they
yeah,
kind of elaborate?
yeah, definitely. I can give you kind of an overview of like the various
Yeah.
themes in RAG that we see people work on.
Mhm.
So, like when you think about RAG, you start on one end. You say, okay, I have a question that I'm trying to ask the system. So the first kind of stop, or the first stop in this journey is the question well posed? And you can
Mm.
have all sorts of issues with like users ask bad questions. They have some intent behind the question, but it's poorly worded. That the question can require lots of like maybe sub questions first to build up to like the final idea. And so there's a bunch of papers, what we call on this topic of query transformation. So it's like taking a question and either like rewriting it to be a better question, breaking it up into a bunch of sub questions, defining a step back question that's like, okay, wait, what's the bigger concept here? Answer that first. So that's
Right.
like bucket one. Like step one on this journey is like query transformation. Like, can I modify my question to make it easier or better align with my documents? That's like step one. And then step two on this journey is like, okay, I have a better question. Routing. So like where does it need to go? You mentioned previously, like in the real world, you don't just have one database, you might have several. A great
Mhm.
example is you have a graph database, a relational database, and a vector store. So like you need to route the questions to the right place. So routing is another whole big area. So we have query transformation, then routing, then you have query construction. So you have a natural language question. You need to map that to the DSL of each data source. That's your text to SQL, text
Right.
to cipher, or even with vector stores, you have metadata filters. So it's text to metadata.
Mm.
So I think of our flow, we have query transformation, we have routing. Then for every data source, we have query construction, like writing it in the DSL necessary. So then that's it. Then there is indexing. So like, how have you built your data source and which have you chosen? There's a bunch of tricks in indexing. Um, one that's really popular that we see a lot of is what I kind of call like multi-representation indexing. There's a bunch of cool papers on this, but basically, if you have a document, typically you think I just chunk that document and embed it. But the document can have lots of redundant things that aren't like essential to the meaning. So one trick we've
Right.
seen is take a document and just summarize it, embed the summary, use
Mm.
the summary of the document for retrieval, but then return the raw document to the LLM. So decouple what you embed for retrieval versus what you ultimately pass to the LLM. That's a really nice trick, and it works
Mm.
really
That's
well
cool.
for lots of yeah for lots of different types of content. Like actually, I've used it a lot for images, and the idea there is if I have an image, I can actually use a multimodal LLM to summarize it and embed the image summary.
Hmm.
And it's easier then because then I'm just using text embeddings to look up an image summary, and then I retrieve the raw image, pass that to my multimodal LM, as opposed to needing like multimodal embeddings, if you see what I'm
Right.
saying. So that's
Yeah,
one good
totally.
example of this
That's awesome.
idea.
Hmm.
So then we have like query transformation, routing, query construction, index construction, ideas like multi-representation indexing, post-processing. So then like you have a bunch of documents back from retrieval. There's a bunch of cool things out there, re-ranking, um, document compression. So like maybe you can summarize them. And then the final thing is generation. So there's like transformations, routing, construction, building your index, post process the what you get back, generation. Pass those to the LM. And that's kind of like the whole RAG flow.
Hmm.
In terms of like entry points, like, the thing we see a lot of success with is designing your index in a smart way. A lot of people start with just chunk optimization. So think about how you're chunking your documents, and a lot of vector stores and patent graphs as well. I'm sure you have to think about like the minimum stored unit that you're using for retrieval,
Yeah.
and that's where like um, there's a lot of interesting ideas related to like how you chunk and split your documents that people play with.
Yeah.
And we could dig into that. There's some really good videos on that, but I'll link in the show notes. And this multi-representation indexing trick that I mentioned previously is another good one that we have some nice templates out of the box for. I can share.
Right.
So anyway, that was a mouthful, but that's like kind of the whole RAG flow is like transformations, routing, construction, indexing, post processing, generation, and then in each of those buckets you can try different things.
Right. And so this is what's so great about the anyone who's coming into this fresh is that you've kind of walked these paths before. These are well-trodden
Right.
paths. Like each time you kind of walk down them, the path is a bit more well-defined. And so even if people are a bit intimidated, like, okay, all the things you just talked about for people who are new to it, that seems like, oh
Right.
my God, this is a lot of complexity.
Right.
Kind of within the Langchain setup of this stuff, you don't have to do it all at once. You can start with one bit and add on, right?
Yeah, of course, and that's like a very important point. Like we actually have existing templates that work out of the box for a lot of these things individually.
Mhm.
We actually don't, and in fact, we don't even have templates that do them all. And I don't think it's depends on your application. It's not necessary to do all these things, but like we have templates for like just query transformation, you
Mhm.
know, just in some indexing trick, just post processing, and then you can easily, if you like one of those techniques, you can really easily compose them. You can
Nice.
combine like, yeah, it's just like another. You think about laying out your chain. It's just like another block in your chain. You just add. So you say, okay, I want post processing. I like that. So it definitely, we have a lot of templates that let you test each one of these things individually, which is probably the right way to do it. And then, of course, you can really easily compose them all together if you want. Um, I will flag though, one of the most important things, like this is one of, and I've actually just hit this doing that Langchain expression language teacher project, right?
Mm.
Running evals is really one of the most important things you can do in the layout of any of these applications. And so it can be as simple as if you're building a RAG app, just define 5 question answer pairs. And you don't have to use Langsmith to do this. We do support evaluations, and I would encourage you to use Langsmith just because I work at Langchain. But of course, you can try other frameworks as well. But running an evaluation is extremely helpful because I've actually found, even very recently with this coding assistant, the simplest method actually can sometimes work the best. And I'll give you that in particular for that case. What I'm seeing right now is actually retrieval altogether does not do better than just taking, and so maybe I'll walk back. It's a coding assistant for Langchain expression language, which is this like syntax we have for building chains, right?
Right.
We have a bunch of documentation on it online, of course. And so the idea was 2 different possibilities. One, just scrape all the documentation, feed it into the prompt of the LLM as just like part of the context, no retrieval, just stuff it all in there and then let it do QA. The second option was build a RAG app. Like we already had out of the box, we had an index of all our documents. So like build a RAG app with our index documents and like do retrieval, right? And you would think like the fancy RAG app's going to do better. It's like more sophisticated versus just the like take the docs, stuff them into the prompt, let GPT-4 128K do the rest. That works better. And like, why is that? And then you get into the details. I've done a lot of it. And this is where I ran evals to show that. And it's like, well, retrieval is not always trivial. Retrieval has precision and recall problems. You introduce a lot more surface area for mistakes. And in that case, the docs were small enough that they would all just fit in context. 128K is a big context window.
True.
That's hundreds of pages, right? So you can stuff them all in. And actually, GPT-4 is very performant at reasoning over a very large context. So that's a good example of this point when you're building the applications. I mean, start simple because actually we found that RAG in that particular case did not outperform the most trivial thing possible, which is context stuffing.
Right.
And I also found, and another fun one there is I found that we tried a more sophisticated RAG strategy still, which was like, I don't want to bore you, but basically generate a bunch of sub questions, retrieval, answer each one, and then pass those QA pairs into an LLM and let do the final thing. The point is, performance was not good. And it was because through all those little retrieval and LLM calls, you just blow up the surface area for making mistakes. And I had a lot more hallucinations.
Yeah.
Wow.
And you think about, well, you're making like, God knows how many LLM calls in that chain. It's just higher complexity, more surface area mistakes, more opportunity for hallucinations, context stuffing, simple, clean, push the context in. That's all you do. No retrieval. And it's performing notably better than the retrieval-based method. So I understand that that does not work for all applications. In many cases, your data far exceeds what you can put in context. But again, it's a good example of build your eval set, run your evals, think about your problem from first principles. Sometimes the simplest methods actually work better. And in that case, we found that like the simplest was actually the most performant. We have pretty good reasons as to why. Retrieval introduced lots of new surface area for mistakes, and I believe the many different LLM calls in the multi-vector approach just introduced lots more opportunity for hallucination.
So it's like there's some sort of you're almost describing like you should start with the minimal viable chain. Do the least amount possible, right?
Yeah.
The least amount possible. I think that honestly that is really a harder lesson. I think it's even step 0, build a little eval set. 5 question answer pairs if you're building a RAG app. Super simple. Build an eval set, build a minimum viable chain, MVC, and evaluate it, right? And then ramp the complexity, evaluate and sometimes indeed you need complexity. In this case, less was more.
Right.
And if I hadn't run the evals, I would have, in fact, our intuition was to jump to the more sophisticated multi-query thing.
Yeah.
And I actually built that first, and then I kind of went back to the MVC and found, actually that's the one.
I mean, I think that's a very common thing for developers to do in general, though. They want to do fancy stuff. They want to, you know,
Yeah, that's
pull
right.
all these complex pieces together and overcomplicate things. And in
Yeah.
reality, you don't always need that. Now, yes, some of
Yeah,
those features are super nice and necessary for certain things, but I think we add more work and stress onto ourselves sometimes by trying to
yeah.
overcomplicate. So,
I've fallen into that trap way too many times myself. I
oh,
think I
oh,
think
same.
yeah, exactly. I mean, I think what happens is as a
Guilty. Yeah.
developer, yeah, you start with with intuitions, good or bad, about what you think or how a project's going to go. And this is why evaluation is just so important. I mean, it's obvious. Most I don't know people recognize
Oh,
that, but like
I,
you just have to. You need an evaluation to kind of cut through that like those intuitions and biases you may have, and it can lead you to non-obvious results. Like, oh, in this case, less was more.
and I think people probably picked up on this through the conversation here, but like, let's take one step back on like,
Mm,
so for software developers, when you hear evaluation, when you hear people in Gen AI talking about eval, we're talking about basically running tests on
right.
how the stuff is working, right? So if you're used to unit testing or integration testing, it's kind of, you end up with the same levels of like things that you can test out, see if it's getting the answers you need. Um, that's a fair way to think about it, right?
That's right. And so for Langsmith and RAG, for example, it's super simple. Build a CSV of question answer pairs for your domain. Like for me, it was code, right? So it was like coding question answer, right? That was it.
Mhm.
Say take 5. Upload that CSV into, in our case, Langsmith, and then you have like an eval set. And here's where it's a little bit interesting. Um, you have your chain laid out, and what you do is you basically call your chain. We have some boilerplate code that lets you say like define basically some eval config that says, here's my chain, here's my eval set, run it, right? So whatever, it's a couple lines of code. But what's interesting is you can specify the evaluator you want. And so this is where it's a little bit non-obvious. So what happens is you take the question, you send it to your chain, the chain spits out an answer, and then you have your ground truth answer, right? What we'd use is we actually use LLM as the evaluator itself. So an LLM
Mm.
looks at your generated answer and the ground truth answer and reasons about the similarity of correctness. And
Okay.
there's a whole bunch of work on this, and like OpenAI actually put a bunch of stuff out on this, Anthropic as well, on kind of LLM guided evals. It's like a deep topic and it's really interesting. The high level intuition is that like LLMs are pretty good discriminators. So it's given like two pairs, like here's a student answer, here's the ground truth answer. It's pretty good at reasoning about it. And so
Okay.
that's what we do. And then we have like a nice dashboard. We can go back, look through your result, and you can look at like, here's all my questions. Here's what the LLM grader graded it, good, bad, and this is all in Langsmith. It's really easy to use. But I will say that LLM mediated evaluation requires attention. You should manually review the results to convince yourself that it's correct or not. I wouldn't just blindly accept what the
Right.
LLM grader says, but at least it gets you really far down this road of a systematic way to evaluate the outputs of these things, which is otherwise non-trivial, right? Because a lot of
Mhm.
times you're evaluating language, like it's even hard to believe eval sets a lot of times. Like, what is the correct answer? And so that's why these
Mhm.
LLM based semantic evaluators aren't bad. I didn't found honestly for code, it's not bad. Like I manually went through, I built a large eval set. I manually went through and tested code execution on every single answer and compared that to like just the semantic grader, and it's like pretty good. So it's
Okay.
not perfect, but it's like it's directionally right. It gets you probably 80% of the way there, and you should manually review.
Yeah.
But so anyway, that's kind of how these things work.
Do
It's
you
still a
have some
very active area of
intuition?
research.
Do you have some intuition about like kind of, I guess, how much you need to eval? Like, is there like a proportional to the size of the data set? Like, if you've got
Mm.
100 gigs worth of PDFs, do you need 1 gig to test, or like, what's your intuition say there?
Yeah, that's
I
actually
know
kind
this
of a
gets
tough one. Yeah,
yeah.
you know what? There's like a lot of different views on this. Like in classical ML, you have like kind of test train splits, and then there's like kind of good heuristics in those domains as to like how big you want your train versus test splits to be. But in this domain, we're talking about like I have this chain that I've constructed. I'm just trying to like benchmark it on a bunch of pairs of examples.
Mhm.
Um, I don't honestly, I don't want to say a number because like I don't have a great sense for precisely what I can give you in the case of like a lot of things we've built on the order of like 25 to 50 questions is kind of what we've used. That's not systematic though, and like it's not particularly like rigorous. It's just it's almost what's kind of practical. Like it
Right.
is, and this is actually an interesting topic. It gets into, you can also have LLMs generate your eval sets, like auto generation of eval sets.
Hmm.
I think maybe the key point I would highlight is like, you want something that you can actually manually interpret. Like, I'll say it like this. Let's say we had an LLM build a 1,000 question eval set for us. You could do that feasibly. You run your eval, you get a score of 75%. How do you actually validate that? You can't really. You have to go through. It would be incredibly tedious, right? So
Yeah.
I actually kind of like to say, just even if it's underpowered in terms of like number, build a small eval set that I can actually manually like inspect.
Hmm.
20.
Right.
Inspecting
Right.
20 answers took me 3 hours last night. So it's
Hmm.
feasible, right? It's tedious, but like completely doable. And at least I have real confidence as to what's going on. So I
Hmm.
think that's kind of the practical thing here. You could build an arbitrary large eval set, but like, can you actually believe the results? Can you actually interpret it? Can you go through
Yeah.
and look?
Yeah.
I argue it would be worse to build a huge eval set and you don't have the bandwidth to go like actually review, and you're just believing it. Oh, and you blindly believe it, versus a small eval set that you actually look at every single answer yourself and manually verify is
Hmm.
better. So again, it's kind of a less is more thing. You know what I mean?
Yeah.
And
Yeah.
and
Yeah.
also, I would encourage, build your own eval set, build it yourself. Don't use like an auto generated thing. So then you have a few really highly curated examples that you actually believe that you can actually manually review, and you learn a lot more. For the coding example, that's how I really learned, like, oh, this hallucination is a real problem when you do the multi-query thing, and there's lots of reasons why there might be. Ooh, like retrieval is a real issue
Yeah.
for the base case RAG, you know, precision recall issues in retrieval. And then, oh, the context stuff is actually pretty good. It misses as few small mistakes here and there. So I was able to actually like completely understand what's happening with a smaller eval set that I actually curated myself. Yeah, so that's probably
Yeah.
the way I would
Awesome.
encourage.
A
Less is
lot of good
more.
thoughts, a lot of good things to keep in mind.
Oh
Yeah,
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 yeah.
and this is something we could probably continue on for hours more.
Yeah, yeah,
I
yeah.
I
For
Yeah, I
think.
know.
sure.
I know we're
Like
kind of on time.
I'm resisting
Uh,
that. There's a bunch of things, yeah, I want to follow up on.
Yeah, yeah, yeah.
I know,
Yeah, yeah, yeah,
same.
absolutely.
But
Well, I'll
but
I'll leave up list in the show notes.
for
I'll put all this in the show notes.
great,
Cool.
yeah. For those of you not
Mhm.
maybe watching, it's getting really dark outside where I am,
Yeah,
so
changing.
I'm
Yeah, yeah,
losing my
yeah.
daylight really
You're
fast
losing
here.
light. Yep, absolutely.
So, so we'll just kind of segue, I guess, now into like the tools of the month, and we kind of like to highlight things that each of us have been working on and are really enjoying playing with. And it's not necessarily, graph related or even Langchain related, but just everyday tools. So, does anybody want to go first?
Go ahead,
Okay.
Andreas,
I'll lead
or
off,
Jennifer. Yeah.
and it's this is new to me because I'm not natively a Pythonista, and so I'm learning a lot about the Python ecosystem. And like, so if I was going to build UIs in the past, I would just pick up TypeScript and like do some React stuff, and that'd be my life. But I've come to appreciate this library called Streamlit that you can use
Oh
from
yeah.
within Python apps and just build really nice looking UIs pretty simply, and it's
Yeah.
pretty nice. I don't know enough about it to be able to compare it to like versus building a React app, like where the trade-offs are, but the kind of the out of the box, you can just get something put together that's nice is been really lovely. So if you're like me and you're new to Python, but you still need to build some UIs, definitely go check out Streamlit. And I think at this point, there's a bunch of other something lits out there. There's almost like a family of something lit UI building tools within Python. That's what I've come to see. So that's
Yeah,
my
and
recommendation for
and
this
I
month.
and I can actually back up Andreas's tool of the month here. I also am not a Pythonista, nor do I have very much experience building UIs, and I've also been kind of playing a little bit with some of the Streamlit stuff. And Andreas is right. There's some things that are pretty nice, and it's once you kind of get into it, it's much less daunting than what you anticipate as a non UI person here. So
Yeah. I'll add another plus one for Streamlit. I'll throw one other out there for you. If you guys are interested at all in like local LLMs, like running
Yeah.
models on your computer, on your laptop, for example, there's a tool called Olama, which I'm a
Mhm.
big fan of. It is very easy, kind of like one click to download like the app itself, and then to grab a large number of open source models and just run them. It's like a one liner, like Olama pull model name. You can do all sorts of things like Llama 2 and like a lot of the newer models are in Olama, and then you just like, there's a new SDK for it. You can just like Um, yeah, just like interact with it on your computer. It works really well with like Macs, although other environments as well.
Cool.
Highly recommend Olama. Really cool for local models.
I love that. That sounds fantastic. I want to go play with that a bit more.
Yeah,
This is again for people who are new to this area. Like, okay, large language models are large, but actually, you
right,
can run some of this stuff on your laptop.
Yeah.
You don't
right.
need to have Google's resources or Microsoft's resources to
Oh
do
yeah,
this kind of work. Right? To build it, you need heavier hardware, but to
Yeah.
run this stuff, you can kind of get away with less.
absolutely.
Yep. And mine is just going kind of back to basics. So I'm choosing Git for this month. I've of course, as most developers, if you interact with some sort of version control, Git is a very, very popular one, whether you're using GitHub or not. But I've been playing a lot with GitHub and actually working on a collaboration project with several people with GitHub, and just a lot of the commands to kind of fork and merge branches and collaborate on code projects. You forget sometimes how cool it really is and how powerful it can really be, and just pulling in everybody's changes and merging that with your code and pushing stuff up for people to look at, creating PRs for people to review before you like push code into a critical branch or something like that. It has kind of reminded me and refreshed me on a lot of the commands that I don't use every day, as well as just how really cool and powerful and collaborative this tool really is. So if you're not using it, check it out, or maybe just sit back and take some appreciation for some of the stuff. So
I'm going to give a +1 for that, even though it seems like okay, Git is kind of everywhere, but I think it's so everywhere that people don't maybe appreciate like when you weren't using Git, if you're using I don't know some version or like something even older models of doing version control,
yeah.
Git is so nice and forgiving. Like there's so many commands you need to do, and I find like whenever I screw up, Git's super helpful in helping me like, hey, you probably meant this. Like, oh,
Yep.
yes, thank you, Git. Thank you for right.
Guiding me in that right
Awesome.
direction. Yeah.
Yeah, totally.
All right. Well, this is the part of the episode where we allow our guests to kind of exit. And as we're recording late on a Friday, well, late for me, I suppose. Um, and if Andreas were in his normal time zone, it'd be really late for him. Um, but yeah. So thank you so much, Lance, for
Yeah,
coming on and chatting and all of the excellent information you provided. I will be sure to ping you about your show notes, links, and resources that you want to provide, and those will all be included for anyone interested.
absolutely. Yeah, it was a lot of fun. Thanks so much. Sorry, I probably talked too much, so sorry about
Never.
You were
yeah,
super.
you
Well,
kind of got me going. You got me going on some stuff. So
That's okay.
yeah, it was good.
That's what this platform is for. So, all
Yeah, yeah, for sure. All right.
all right.
right. Thank you. Have a good rest
Thanks
of
a
So
your
lot.
weekend.
Yep. All righty.
time for Neo4j news.
Yes. So just a couple of things I'm going to highlight. We won't keep everyone on here for too much longer. But there are a couple of articles that are sitting out there. I know it's January, so not a ton of progress yet. That'll be later. You'll get hit with the fire hose maybe, um, but a lot of things out there actually on RAG and LLM stuff, which is still quite popular. So the first one is why vector search didn't work for your RAG solution. This is out on the Neo4j developer blog, and I worked through that. Read it. It's a really good article that kind of takes the movies data set and pings different questions with the LLM and shows why a question worked really well, some hallucinations LLMs might have. Trying to negate or add negative data inside the data set and seeing how the LLM responds to that. So it was really cool just to kind of get an idea of different, I guess, kind of variations of things with an LLM when it works really well and when maybe it hallucinates or tends to do worse. The next one was taking YouTube transcripts into Knowledge Graph for RAG applications. Another really cool one, just kind of showing you how to ingest data. I think it used GCP to push the YouTube videos up and pulled the transcripts out into chunks and then looked at that inside a graph. Neodash did some graph dashboard stuff. There's some new things going on there. So if you're in the Neodash space, definitely check that out. There's a new article on Medium for that. talking about graph and LLM powered RAG application from PDFs. So taking a lot of articles that this author has written before, a lot of conceptual information, and actually building an application and showing how this works in practice. It was really cool. And then the last but not least was unlocking DAGs in Neo4j, which is directed acyclic graphs. So there's some new GDS procedures and showing just basically how those operate. As always, there's some new stuff coming out in the Nodes 2023 playlist. So if you're more of a video type of person, be checking on that. I know there's at least one or two that have been added this month. So keep an eye out for that. And then just a couple of events just to wrap up the whole segment here. J-Focus in Stockholm, Sweden is on February 5th. Just a quick shout out from my personal past is I've been to this conference a couple of different times. It's a really awesome event. So if you have an opportunity to go, definitely check that out. There's a meetup on February 8th in Kansas City, Missouri. Actually, I'll be presenting that one. It's on improved results with vector search and knowledge graphs. On February 13th, there's also a meetup in Brisbane, Australia. And on the 21st, there's a virtual meetup that I'm presenting, Hallucination Free Zone, LLMs, and Graph Databases Got Your Back. February 22nd has a Graph Summit London conference and a Developer Week conference in San Francisco. So you've got London and San Fran on February 22nd. There's a meetup on the 23rd in Bangalore, India, with a hands-on workshop on GenAI Stack. And wrapping us up, we have a conference in Amsterdam, Netherlands called DevWorld 2024, and that's on the 28th. So anything else, Andreas?
That was plenty. I don't think we need much more. I
Yeah.
was a little disappointed that DAG wasn't something to do with LLMs. DAGs and RAGs, I don't know.
Yeah, that's true. That's true. Yeah. Yeah, that's initially when I pulled up the article, that's what I thought of as well. But it was not. It's GDS procedures. So all right. Well, thank you everyone for joining us on this session, and we will talk to you in the next month.
Goodbye, all.
Bye.